Okay, let's see. This is the digital clock with the help of RGB LED strip. This is ws2812b, which can run on the 5 volt. Okay, see, this is the red one is our minute. Okay, and this blue color, which is our second, and this fast rotation is green one, which is millisecond. So full round of the millisecond, increment this second LED blue, and full round of this blue will increment this minute LED. Okay, so it is just like second, minute and hour. We make it millisecond, second and minute. So you can see now incremented by 1. So it will happen in continuous loop, and in the same way we can make our minute hour clock or second minute hour clock. Okay, let's look at the working of this ws2812b RGB LED circuit. So this is I am drawing the timing. So when we are giving 75% duty cycle, then it taken as 1, and if we are giving the 25% duty cycle, then it taken as 0. It means it will remain high for 800 nanosecond and low for 400 nanosecond, then it is 1. And when it is 400 nanosecond high and 800 nanosecond low, then it is 0. That's it. So we are sending 24 bit, 24 into 2 or 24 into 3 bits continuously. After sending these bits, we have to give delay of about 50 microseconds or more than 50 microseconds to stabilize this data. So minimum delay of Arduino is possible 1 microsecond with the delay function. Alternate option to produce less than microsecond delay is timers. Initially we are not using any timer for that purpose. We use the inline assembly programming to produce delay of less than microsecond, that is about 400 or 800 nanosecond. According to the datasheet, we first send green bit pattern, then red and then blue. So it is not RGB, it is GRB. Brightness of LEDs depend upon the 8-bit value. So higher the 8-bit value, brightness is the higher. Inline assembly programming will give the better idea of working of this RGB LED. Okay, this is the RGB LED strip WS2812B. So 5 volt is red, data in is green, and ground, which is white. And you can see this okay, 3 LEDs, red, green and blue. Okay, look at this hardware setup. This is a very simple hardware setup. This is Arduino Mega board. This is small little breadboard. This is RGB LED strip, electrolytic capacitor, 100 microfarad, 10 ohm resistor. This is 1 kilo ohm resistor. That's it. So see the circuit. Arduino Mega giving 5 volt to this RGB LED strip. This is the connection. Red color of the RGB strip to the red color of this Arduino Mega. Then this white color is the ground, which is connected to the Arduino ground through this 10 ohm resistor. This middle one is data in pin, which is connected to the Arduino Mega pin number 3 through the 1 kilo ohm resistor. And this electrolytic capacitor is connected across the positive and negative of the RGB LED strip. This RGB LED strip run on the 5 volt, so we can easily connect it to the Arduino Mega. So we are running total 60 LEDs, RGB LEDs, so it is possible to run without any external additional power supply. Okay, let's see the programming part. So first we have to define the pin for our data input. So we defining the pin number 3 of Arduino Mega as output pin. Then into the while loop we start for inline assembly programming. So we have given here the label begin. Okay, and we will not use that R17 register right now. So we'll see it afterward. Now we are loading R16 with the value 60 for our 60 LEDs and giving the label start. Okay. Then see the green color. What is the green color? So here the SBI 0x0E and 05 is denoting that port E bit number 5, which is actually pin number 3 of Arduino Mega. And then we are calling code 0. SBI, it means the setting that bit, and calling the code is that code 0 and code 1 that we initially seen, that the pulse of with the 75% duty cycle or 25% duty cycle. So we creating that pulse, or we are generating that pulse with the help of this code 0 and code 1 subroutines. So we call those subroutines again and again. Here you can see that repetition. Hex 0E is the address of port E. I am sending 72 bits and I am giving the delay of 50 microseconds. Further two instruction, decrement R16 and BRNE go starts, giving us 60 rotation so that we can go up to or reach up to 60 LEDs. First 24 bit we are sending to glow up the LED, which is blue, and then remaining 48 bits we are sending to blank the or off the LEDs. That means one LED will glow and two LED will off. Let us see what is subroutine code 0. Okay, so code 0 is giving the binary 0 value to LED, that is LED will get off with this subroutine. So into this subroutine we have given CBI hex 0E bit number 5 instruction and then knob instruction. The 14 knob instructions we have given. Now see the code 1 subroutine. Here I am giving 14 knob instruction, then the instruction CBI hex 0E, that is the address of port E, and the bit number 505, and then 6 knob instruction, that is giving us 75% duty cycle so that we can glow up the LED. For refreshing the cycle, I am sending 0 to RGB LED strip for 65 time, and then I jump back to the label begin. Okay, here I am giving the delay of 100 millisecond. Here I am using this R17 register to repeat this pattern for multiple time. Let's upload this program into our Arduino Mega. Into next episode we will see the detailed programming for our RGB digital clock. Thanks for your time.